For years, artificial intelligence had one enormous advantage. Humans had already created much of what it needed to learn. We wrote books, built websites, uploaded videos, wrote software. Then we put nearly all of it online. But robots have a problem. Much of what they need to learn was never written down. Welcome back to Synthetic Politics. On August 21st, Reuters reported that Chinese robotics company Ace Robotics believes humanoid robots are approaching a major bottleneck. Not motors, not sensors, not even computing power. Experience. Ace estimates the entire industry has accumulated only around 100,000 hours of useful, real-world training data. So, Ace is putting sensors on human workers performing real jobs, trying to capture tens of millions of hours showing how people interact with the physical world. A day earlier, Unitree founder Wang Xing described the same problem from another angle. Today's robots move impressively, but models that succeed in fixed scenarios can struggle when an object or environment changes. Generalization is becoming one of the industry's biggest constraints. At the same event, Amoga said it had delivered more than 3,000 robots and was pushing them into dealerships and public spaces. Real environments where experience happens. One company needs experience, another is putting robots where experience happens. Together, they point to an old economic problem. Some of our most valuable productive knowledge lives inside people, not instructions. An experienced mechanic hears a problem before naming it. A skilled worker adjusts grip and pressure almost instinctively. Economists treat accumulated skills like these as human capital, but some of it is difficult to transfer because we know how to do things we struggle to fully explain. Industrialization has spent generations attacking that problem. In the post-war period, U.S. Air Force-backed research at MIT developed numerical control. Instead of a machinist manually reproducing every movement, movements could be encoded as instructions a machine could follow. That eventually became modern CNC. Productive knowledge that once had to reside in a worker could now reside in a program and become much easier to reproduce. But humans still had to know what instructions to give the machine. Skills that couldn't be reduced to explicit instructions remained much harder to automate. Think about catching an object before it slips. Your fingers adjust pressure. Your wrist reacts to its weight. You correct almost instantly. Now try writing down every instruction required to do that. This is what makes ACE's approach different. The worker doesn't have to explain the skill. The machine watches. Sensors record what people do, and a model learns from those examples. CNC required humans to translate skill into instructions. AI may let humans translate some skills simply by demonstrating them. That changes the economics. Teaching one person a skill doesn't teach 10,000 others. But a capability learned by a model could potentially be reproduced across thousands of machines. And human demonstration isn't the only source. Robots can also learn by doing. Economists have long understood that experience itself can improve productivity. Robotics may add a new layer. A robot working in a warehouse, factory, or public space encounters situations as no lab anticipated. Capture those moments, and deployment potentially produces two things: work today and training data for tomorrow. That creates a potential flywheel. Deployment generates experience that can improve future deployments. Researchers have already demonstrated pieces of this experimentally, but we don't know whether that flywheel works at commercial scale. There's no evidence yet that Amoga's thousands of robots are feeding a superior general model. And sheer data volume isn't enough. The experience has to be captured and standardized in a form models can actually use. That may help explain why China is building dedicated facilities where humans teleoperate robots specifically to generate training data. The scarce resource isn't simply activity, it's usable experience. And that could give China's enormous manufacturing base another kind of value. Its factories, workers, and logistics networks don't just provide places to build and deploy robots. They could provide places for robots to learn. That doesn't guarantee Chinese leadership. American firms retain major advantages in foundation models, software, and capital, and nobody knows how efficiently physical experience can become general robotic intelligence. But the economics underneath this race are much older than AI. Knowledge has value. Experience creates knowledge. And industrial history keeps finding new ways to move productive knowledge from individual workers into technologies that can reproduce it. Robotics may be pushing that process across a new boundary, testing whether physical skill accumulated one worker at a time can become something very different, capital that can be copied. Do you think usable real-world experience becomes the binding constraint on who leads an embodied AI? Or will better models and simulation matter more than raw data volume? Let us know in the comments. If this breakdown was useful, hit like and subscribe to Synthetic Politics. We'll be back when there's more to report.